Hi guys, welcome to all of you. Please confirm whether am I audible to you or not. Shillong, are you there? Guys, please confirm once that am I audible to you or not. Every center. Hi, good morning Shillong. Shillong, how many students are currently sitting in the classroom? Eight. Okay, because there is 0 student in the camera actually. I'm not able to see. That's why I have asked it. No, it's okay. Is your cam port 8084? Are you sure? Please check it once. Your cam port is 8080, dear. Now everyone is visible. Hi. Hi everyone. Okay. So let's start guys. I have given you a question in the last class. I hope so everyone has attempted. Few of students have even responded me in the groups as well, or we can say on the messages as well on the WhatsApp. Okay, so really nice attempt guys. So let's check out what is the correct answer for that. Okay, so let me write the question first. The question was calculate volume of 0.1 molar NaOH which should be added in 300 ml of HCl solution having pH equals to 2 to change its pH by 2 units. This one was the last question that we haven't discussed in the class. Okay, that was the homework for you guys. Now please look at the screen, just understand the question. They're just saying that we need to determine the volume of the 0.1 molar NaOH solution. Currently, they are saying the solution having the pH equals to 2 means it contains the acid as well as the base. Okay, so they are saying that how much volume we should add NaOH so that its pH would be changed by the 2 units. Okay, so first of all, let's calculate the concentration. pH is 2. So we can have the concentration of H plus ions equals to what? 10 to the power minus 2 molar. Okay. Actually, this is the solution which contains H plus ions 10 to the power minus 2 molar, we have to add the NaOH into this, okay, and we have to change its pH by the 2 units. Means the new pH should be what? 2 plus 2, which is what? 4. It means that it is an acidic solution. Still it is an acidic solution, okay. So we know that for the acidic solution, the concentration of H ions can be calculated as A minus B upon V1 plus V2. Okay, I hope so we know this formula. Now, first of all, calculate the value of A. Okay, so A can be nothing but 10 to the power minus 2 into 300, which is equals to what? 3. Okay, if we need to determine the B, means moles of base, see we do not have any information about the volume, so just take it as a V, but yes, we have a concentration, so this is nothing but what? 0.1 B. Okay, so now just put these values. See, concentration of H plus ions would become 10 to the power minus 4, this is 3, this is 0.1 V, this is 300 plus V. Now just solve this. Solve this, you will get your answer. 300 in 10 to the power minus 4 plus 10 to the power minus 4V. (300) 4 into V equals to what? 3 minus 0.1 V. Okay, so this is 0.03. Minus 0.03 equals to what? 10 to the power minus 4V plus 0.1V. Okay, so when you will solve it, volume should comes out to be what? 29.7 milliliters. This is the answer. Guys, have you got that? Are you clear with the solution? Please confirm once. Okay, please copy this one. Please copy now, and after copying that, just inform me once. Everyone, please copy. Okay, copy this one as well. Done, guys? Hi Tamilong, welcome. Okay. Okay guys, so we have discussed that how can we calculate the pH when a strong acid is being mixed with the strong base. Okay, so obviously after mixing of that we got a salt. Okay, now this salt is being hydrolyzed. Okay, and that can change the pH. Okay, so now it's the question that how it can change the pH. Okay, so now finally we are going to start with the salt hydrolysis. So we are discussing actually the first case. Already first case is started. Now the topic is hydrolysis of salt of strong acid and strong base. Just look at the screen, guys. Need not to copy anything. First of all, understand the meaning of this one, because I'll discuss only the two cases, or might be the only one case, and after that I'll just write the formulas for you. You have to remember those formulas only. Okay, means yes, you need to understand the concept as well. So I'll discuss the concept with one of the case. Okay, rest case I won't discuss. I'll simply deal with the formulas. Okay, so hydrolysis of the salt of the strong acid with a strong base. We know that whenever a strong acid is being treated with a strong base, we get what? A salt and water. Now this salt can be ionized to give you what? Na plus ions and Cl minus ions. Okay, now let's check out. See, if we talk about Na plus, hydrolysis means reaction of this one with the water. If I treat Na plus with the water, what will be the product? What can we say? This is what? NaOH plus H plus ions. Okay. I'm repeating, guys, do not copy this. If I say Cl minus on treatment with H2O will give you what? HCl plus OH minus. Okay. Actually, the point is these reactions are not favorable. Actually, these are not possible reactions. Guys, I'm repeating, please do not copy this. I'm repeating again, do not copy this. First of all, understand it. Okay, because I'll make some changes into it. That's why I'm saying it. Okay. So what I was saying, that the Na plus on treatment with the water give you what? A strong base. Okay. Whereas the Cl minus on treatment with the H2O will give you what? HCl, a strong acid. Okay, we know that the reaction proceeds from strong to the weak part, not weak to the strong part, that we have already discussed. Okay, so these are not actually favorable reactions. Okay, or if you want to understand more, you can simply figure out that Na plus has got a noble gas configuration. Okay, if a substance has already got a noble gas configuration, then it won't be further treated unless drastic conditions are present over there. Similarly, the same case is applicable with the Cl minus as well, which is in Cl minus, which has achieved the noble gas configuration. Again, that it won't be further treated. Okay, with the water. Okay, so these are not the favorable reactions. That's why they won't produce any H plus ions or the OH minus ions. Therefore, we can say that pH would be the 7. No hydrolysis occurs here. And it is a neutral solution. Okay. So what I was saying, that whenever an ion is coming from the strong part, whether it is a strong acid or a strong base, it won't be further treated with the acid or a base. Means it won't react with the water, because it is already in a very highly stable state. Okay, or this reaction won't be the favorable one. Okay, so that reaction is not possible. So the ion which is coming from the strong part cannot affect the acidic or basic strength of the solution. Means it won't make the acidic or the basic solution. Okay, first of all, you need to understand this one. Okay, so we will say that whenever we take strong acid and a strong base in equal amount, exactly equal amount, the pH will always be the 7. Means they will make the solution neutral. Okay, so I hope so it is clear to everyone. Guys, are you clear with this one? That this solution would be the neutral. Okay. Raise your hand those who are having the doubt. Raise your hand those who are having the doubt. Okay, you are having a doubt. Okay. See, I was simply saying, just listen to me very carefully. I was simply saying, whenever, okay, please do one thing, just copy this once, after that I'll repeat it. Everybody please copy it, then I'll repeat it. After copying that, just confirm me once. Copied everyone? Tamalong, have you done that? Okay, so guys, I'm repeating it. Just look at the screen. See, this is the salt which we have got from the strong acid and the strong base. Okay. Obviously, salt is an electrolyte, so it will always ionize to give you the cation and the anion. Okay. So Na plus, if I simplify this one, I can say that Na plus has got only 10 electrons. Okay, and we know that it is the noble gas configuration. Okay, we know that noble gases are very unreactive. I hope so it is clear to everyone that noble gases are very unreactive. Similarly, the Cl minus has got the 18 electrons. Again, this is nothing but what? Noble gas configuration. Okay. So the point is, if both the ions have acquired the noble gas configurations, it means that they cannot react with the water under the normal conditions. Okay. So they won't react with the water. Okay. So if they won't react with the water, it means that they cannot produce the H plus ions or the OH minus ions. See, here I have put a cross sign. That cross sign is representing that the reaction that we are writing over there is not favorable. Means that is not the possible reaction over there. Okay. So if the reaction was possible, let's suppose we have a condition that this reaction is possible, it means that it would produce the H plus ions and it might produce what? OH minus ions. If in the final solution there is one of the ion, H plus or the OH minus, only then it can be the acidic or the basic. Okay. See, if it cannot produce the H plus or the OH minus ions, it means that it cannot be the acidic or the basic. Okay. So if something which is not acidic or basic is simply what? Neutral. Neutral means its pH should be equal to what? 7. That's what we were discussing. Now are you clear with this one? The students who were having the doubt, guys, are you clear now? Okay. Now the next important point that you have to mark here, that in the case of the strong acid and strong base, the source of H plus or OH minus will be only water. Okay. Solution is definitely neutral. And yes, guys, you can remember this one, very important. Anions which will not hydrolyzed. ClO4 minus, SO4 2 minus, NO3 minus, Cl minus, Br minus, I minus. Whenever these anions are appeared in the reaction, you will simply say they want further hydrolyzed. Means they cannot affect the acidic or basic strength. Cations which cannot be hydrolyzed, like Na plus, K plus, Rb plus, Cs plus, Ca2 plus, Sr2 plus, Ba2 plus. Okay, so these are the cations that cannot be hydrolyzed. Please copy. Okay guys, so let's move on. So this was our first case. This was our first case where the pH we have got the 7. Okay. Now let's discuss the case where we won't get the pH 7. Okay. It will be either more than 7 or the less than 7. So this is the case number 2. Guys, please understand this case very carefully. I am repeating. No need to write anything, just look at the screen, understand the concept, and after that you have to copy that. Okay. And yes, I'll discuss this case in the detail, and after that the case numbers 3rd and the 4th, I'll just write the formulas of that. If you want to derive those relations, you can simply take the hint from here. Okay. So just look at the screen, be relaxed. Okay. Just put your pen into a copy and write it and keep it on the side. Okay. So this is the case. Hydrolysis of salt of strong acid, weak base. Okay. So acid is strong, so I am considering it as a HCl. Weak base, I have considered it as a ammonium hydroxide. So I'll get the ammonium chloride with H2. Let's consider they have the concentration C. This one will be nil initially. Now this is the salt which will have the concentration C. H2 is in the pure liquid state, so just leave that, we need not to consider that. Okay. And we are assuming that this is completely finished. Okay. This is completely finished. Now, let's talk about ammonium chloride. It will give you what? NH4 plus and Cl minus. Okay. Initial was C, this is 0. After that, this one will become C. This is nothing but what? C minus. No, this is the electrolyte, na? So this is completed. Okay. So remember, these are the salts, and salts won't have any concentration after the completion of the reaction. Okay. See, this is just the information section. Now we have to deal with them. First part, general hydrolysis reaction. Guys, just look at the screen. See, in the salt we are getting the ammonium ions. So ammonium ions on treatment with water can give you what? Ammonium hydroxide with H plus. Okay. So I'll write the KH. KH stands for the hydrolysis constant, which is nothing but what? Concentration of the product upon concentration of reactant. This is the equation number 1. See, I won't consider the water. Why? Because water is in pure liquid state, and we know that pure liquids and solids are not considered while writing the equilibrium expressions. Okay, so that's why I won't write it. First of all, tell me, is everything clear till now? Everyone, please confirm. Is everything clear till now? Okay, very good. What happened, Balajit? What are you doing? Okay. Number 2. The relation between KH KW and KB. See, we know that KW is nothing but what? H plus and OH minus. Okay. And KB would be what? You can write it for this reaction KB, na? Ammonium hydroxide can give you what? NH4 positive and OH negative. So you can say KB would be what? NH4 positive and OH negative upon NH4OH. This is the equation number 2. This is equation number 3. Just divide these two equations. Divide equation 2 with equation number 3. We will have KW upon KB is equals to what? NH4 plus one second 2 by 3 now KW upon KB. Yes, so this is H plus OH minus upon NH4 plus OH minus and NH4 OH. So you can see that this one has got cancelled out, and the remaining part is representing nothing but what? KH. Okay, remaining part is representing nothing but KH. So this is KW upon KB is equals to what? KH. One more relation. Are you clear up to this? Everyone, please confirm. Are you clear up to this? Okay, you can copy this. You can please copy up to this. Then we will proceed. Please copy and then confirm. After that, we will proceed. Copied. Copy this one as well. Copied. Copy this one now. Any doubt about it, guys? Are you clear with this one? Tamelong, Shillong. Please raise your hand, those who are having the doubt. Now you're confusing me. Are you anyone having the doubt? Raise your hand. Oh, no one is having the doubt except me. Okay, thank you. Okay, let's move on, guys. Remember, might be it looks a little bit bigger, okay, but yeah, it is very easy. When you go through the whole this, you will find out it's a very easy, okay. And at last, you have to remember the formulas. I'm telling you, okay. So let's continue. Part number 3. Relation between KH and H. Now the question is, what is H? See, till now we are discussing about the alpha. Alpha is nothing but what? Degree of ionization. Here we are discussing about the hydrolysis. So alpha, that alpha is now replaced with the H, and this represents the degree of hydrolysis. Means how much part is being hydrolyzed. Degree of hydrolysis. Again, we will deal with. We will deal in the same manner. So let's check out. Ammonium ions on treatment with H2O can give you what? NH4OH with H plus. Okay. So let's say suppose this is C, this is 0, this is 0, this is CH, this is CH, this is C minus CH. Okay. So let's check out. I'll write the KH. This is nothing but CH square upon 1 minus H. I guess so you have learned such type of formula. Okay. But yes, you have to remember, if H is less than or equal to 5%, in that case, your 1 minus h would be nearly equal to 1, and then kh will be equals to what? Ch square. Okay, is the formula. Number 4, derivation for pH. Are you clear with this one? Everyone, please confirm me once. You have to copy this first. Is everyone clear with this one? Please copy this one. Copy and then confirm. Done. Copy please. Copy everyone. Okay. Now we know that H plus is nothing but CH. Okay. So I can put the value of CH here. We know that KH equal to CH square. So CH would be what? From here, KH okay, I need to calculate H now, KH by C under the root. This is the value of H. Okay, so I can get the value of H from here, and I'll simply put that value over here. So it will be C into under the root KH upon C. So if you solve that, on solving, you will get H plus is nothing but under the root KW into C upon KB. Okay. Why we are getting the KB? Because I have put the value of KH as well from the previous equation that we have driven in the case number 3. Okay. Now just solve this, and after the solving you will get the pH is equals to half of, ultimately you need to remember this formula, pKW minus pKb minus log C. This is a final formula that you have to remember. Please copy. So at last you have to remember this formula only. So we have driven the 4 formulas that you have to remember for the exams. Okay, please copy. What happened, Shillong? Why attendance is very low? What's going on, guys? Tamelong, please mark your attendance. Wow. Attendance is suddenly changed. Okay. Okay. So please copy this one. And hi everyone, those who are latecomers. Please be on time. Okay. Yes. Otherwise, next time I'll talk to everyone then. Everyone as in those who comes late. Okay. So guys, I hope so it is clear to everyone. Guys, it is clear. Is it clear to everyone? Please confirm me once. Are you clear with the second case? Okay. See, few students are just busy with their chats. Okay. So guys, let's have a question first, and then we will move on to the case number 3 and the 4. Okay. Derivation number 4. Okay. Are you saying that how do we get that formula? C went to the top. Okay, I'll explain it. Please look at this, guys, everyone. This is K H by C, no? KH by C. Okay. Look at this. Under the root means power is half. Okay. So this is nothing but KH upon C to the power half. Okay. Now I can write it. This is as KH to the power half and C to the power half. Okay. We know that whenever any quantity changes its position from numerator to denominator, its powers has got a different sign, means its sign is changed. So what will happen, that when I take this one into the numerator part, so this one will become what, C into power minus 1 by 2. This is KH to the power 1 by 2 default. We know that power got added, so this is the power 1. So when you add this is 1 minus half KH to the power half. So this is T to the power half into KH to the power half. Power half means what? Under the root simply. So this is nothing but under the root KH into C. So just put the value of KH and you will get your result. Now clear? Okay, now let's have a question now. Okay guys, so I'm writing the question. See, again I'm repeating, this is now the formula section. Okay. And I have told you that you have to prepare a formula booklet. How many of you are preparing the formula booklet? Raise your hand. How many of you are preparing the formula booklet? Means you have prepared a different book of the formulas only. Only Ernie has raised his hand. What about others? Okay, Balaji is also saying yes. Then I guess so Formwell is also saying the same. Then rest of are doing nothing. Why guys? Oh, probably he is not Formwell. Then he might be the Paul or Nitish. Okay, Paul is at the last, I guess. Oh, Shem. Sorry. So Sham is also maintaining that formula booklet. And what about others, guys? Why are you not maintaining that formula booklet? Okay, for the winter vacations. Okay, so guys, please maintain the formula booklet. It's very important. That is the micro notes for you. Okay, that will be really very helpful at the last. I'm telling you. Okay, for the registration. Cool. Okay. And yes, guys, please register. Sorry, as soon as possible as the forms has got released. Okay, and dates are also being set that you've at what date you will have your examination. Okay, so it is just like sample formula booklet. Okay, you need a sample that how you can get how to prepare the formula booklet. Okay, I'll give it. I'll send it in the group. Okay, I'll send it the sample formula booklet. Okay. Yes, guys. So now everything is set. Now dates has been released. Okay. So this is the time to maximize your efforts, your efficiency, your brain, everything. 10 times, 100 times, 1,000 times. Okay, nothing but only that examination. Okay. So please be prepared for that. And whatever need you help, just let me know that you need help in this one. So I'll definitely make sure that I'll help you. Assignment of the chemical bonding. Okay, I'll provide you the assignment of the chemical bonding. Cool. And yes, I know that we have to discuss the questions of the structure of atom, in doubts of the structure of atom. And tell me one thing, how many of you are practicing the MTG book that I have provided you? Previous year's NEET questions. How many of you are practicing? Okay. This time many, not many. Okay. Guys, and I hope so you are not facing much difficulty while solving those questions, because these are very simple questions. You find out, you will find them. Okay. So, but yeah, practice is must. I'll provide you the assignment of the chemical bonding, and yes, I'll discuss the doubts as well. Okay. And yes, guys, please do not wait much for the doubts. Just post your doubts in the groups. Those groups are been prepared for you guys. Okay. I guess only 2-3 times I have got the doubts in those groups. Okay. Please, everyone. So just do this question, guys. Calculate pH of solution obtained by mixing 200 ml of 0.1 molar NH4OH having Kb equals to 10 to the power minus 5 and 200 ml of 0.1 molar HCl. Tell me the answer. And yes, you have to calculate the and also calculate KH and H. Please attempt this question. Once you have completed, just let me know. Yes, absolutely right. KH is correct. I thought you have calculated the pH. Where is pH? No, not 1. Okay, look at this. Look at this. This is HCl. This is ammonium hydroxide. Will give you what? Ammonium chloride and water. So obviously don't expect that they will give you the straight values. Okay. Yeah, they can give you, but we will do the questions where we will calculate those values. They are saying the 200 ml of 0.1 molar ammonium hydroxide. Guys, always try to deal with the millimoles. Okay. See, first of all, calculate the millimoles of the ammonium hydroxide. So this is what, 0.1 into the 200. So this is nothing but 20. These are millimoles I am calculating. For HCl, it is 200 into 0.1, same 20. Initially, they will be 0. So obviously, this one will become 20. This is 0. And we need not to consider this one. Okay. Because in the hydrolysis, I need only the salt. I need the moles of the salt only, nothing else. Okay. Ultimately, I need the concentration of the salt. Guys, try to crack the question. That what actually you need in the question, that the concentration of the salt, how can you get that? Okay, so once you have got the number of moles, now you can calculate the salt concentration. Nothing but moles upon total volume, which is 200 plus 200. So this is 1 by 20. Okay, and we know that if concentration of salt is 1 by 20, and obviously anion will also have 1 by 20 concentration. Okay, so once you have got that, that's all about the question. Half of pKw, which is 14, minus pKb. Kb is given to you, which is 5, minus log C. So log of 1 by 20. Just solve this, you will get your answer. Clear with this one, everyone? Please confirm. Are you clear with this one? Okay, raise your hand. Those who are having the doubt. Okay, please copy. Okay, yeah, I have seen your hand now. Yes, I'll repeat it. Don't worry. Please copy this first. Done? Have you copied everyone? Okay guys, please once look at the screen. I guess if this is the problem, this might continue. Please everyone just look at the screen. Once, then you can solve this. Everyone please look at the screen. The formula for the pH calculation was half of pKw minus pKb minus log C. Focus on this C. This is nothing but the concentration of salt. In the question, they haven't given you the concentration of the salt, but yes, they have given you the concentration of the acids and the base. Okay, so by the help of that values, you need to determine the value of the concentration of salt. So just check out. You have got the HCl and ammonium hydroxide. Okay. See, you have to calculate the concentration of this salt. How can you get that? Okay. Now check out. We cannot determine concentration directly, so we will have to determine the concentration by the help of the formula. Okay, that moles by volume. So first of all, determine the moles of the HCl. See, the concentration of HCl was 0.1 and the volume was 200. So moles of HCl will be 20. Similarly, ammonium hydroxide will be what? 20. Okay, so obviously this is C, this is also C. Okay, initially they will be 0. The all part has been converted into the ammonium chloride. Okay, it means that this is equals to C. Okay, so you have got the value of C, which is what? So sorry, this is not C. Consider this is the moles. Now we are calculating the moles. These are what? Moles. So we have got the moles of the ammonium chloride. So how can we get the concentration? Just divide the moles by volume. Total volume is what? Volume of HCl plus volume of ammonium hydroxide, which is 1 by 20 on solvent. Now get it? Now are you clear with this one? The student who are having the doubt in this one. Okay. Guys, please revise them again. Okay. So guys, on solving, let me tell you something. On solving, the answer would be the 5.15. This is the pH value. This is the pH value. Done? So I hope so this case is clear to everyone. Okay. So guys, let's take a quick break of 5 minutes and then we will continue after that. Okay. I'll see you in the 5 minutes. Hi guys, welcome back. Uh, I think few students are not still back. Okay. Hi. I hope so. Up to this, everything is clear to everyone. Okay. If anyone is having any doubt, you can please ask me. Because now I'll write the formulas of the other cases, okay, and ultimately you have to use those formulas only, okay. So let's begin, guys. Let's start with the next case. Number 3, hydrolysis of salt of weak acid strong base. Okay. So acid is weak, so I'll consider it as a acetic acid. It is a weak acid. NaOH is a strong base, so on treatment this we will get the salt sodium acetate with water. Okay, so this is C, this is nil, this is C ultimately. So we have to focus on these only. Okay. Other than that, obviously CH3CONa will get converted into what? CH3, CO negative and Na positive. Okay, this is C, 0, C and C. We know that this is coming from the strong part, this is coming from the strong part, therefore there is no impact of this one, so I'll simply cross it. No use of this one, so I need to focus on this one only. Okay, this represents the concentration of the salt. Okay, please copy this one. Done. Now, this is a general hydrolysis reaction. Giving you CH3, COH and OH minus. Means this will make the basic solution. Means this finally the solution, the nature of the solution would be the basic by this reaction. Okay. So I'll just write the formulas, okay, the important formulas. First is KH. This is nothing but CH3COH H plus, not H plus, sorry, OH minus upon CH3 CO negative. Okay. Second, KH is equals to KW by KA. Okay. Because one second. Yes. Okay. Here acid would be introduced. That's why we will use the K over here. Next, KH is equals to what? CH square upon 1 minus S. 1 minus H. Remember guys, this C is the concentration of the salt. I am repeating. C is the concentration of the salt. Okay. And yes, if H is less than or equal to 5%, in that case 1 minus H would be nearly equals to 1. So the KH would be nothing but CH square. Okay. Number 4, pH. This is half of pKw plus pKa plus log C. Again, this is nothing but the concentration of the salt. Please copy these formulas. Then after that, I am giving you a question. After that, I'll give you the question. Done, guys? Have you done that? Okay, let's move on. Question. Calculate pH of a solution obtained by mixing 200 ml of 0.1 molar CH3COH and 50 ml of 0.2 molar calcium hydroxide. Ka was 10 to the power minus 5. Please do this question. In spite of writing, wait, this one, just write the NaOH. Please write NaOH. Do not write the calcium hydroxide. Do it. Then tell me the answer. Guys, try to refer the previous question if you are facing problem while solving in this one. Raise your hand those who has completed this question. Can I start this question or you need some more time? Okay, take your time. Okay, pH is 5.05. I need to check it once. Okay, they are getting the 3.65 as well. Okay, let's solve this question. Let's check out what is the correct answer. See, I hope so everyone were doing the same. I have told you start with the millimoles, so let's start with the millimoles. So this is 200 into 0.1 and this is 0.2 into 50. So this is 20 and this is 10. Initially they are 0. And guys, I have told you that the strong acids or the strong bases are considered, or we can say the substance which is having in such type of reactions, the substance which is having the lower value is actually the limiting reagent. Okay, guys, please listen to very carefully here. See, either you need to determine the limiting reagent because they are in the 1:1 ratio. Okay, so I can simply say that the substance which is having the lower number of moles will be the limiting reagent. Okay, If they have the different coefficients, then you need to determine the limiting reagent as well. Okay, so here I can say simply the 10 moles would be formed here. Are you getting this? Wow, this is the new thing now. Guys, please look at the screen. Okay, I noticed you guys, whatever I write it on the screen, you guys either start rubbing something, okay, or you start doing something else. Something else means you start solving that question. See guys, this is not the way to learn something, okay. For the learning, consistency and focus is matter, okay. So just look at the screen and try to listen what I am trying to say, okay. So I was saying here we need to determine the limiting reagent. Limiting reagent will decide that how much salt should be the formed over there. Here the NaOH is the limiting reagent because it is having the lower number of moles. That's why I was saying do not deal with the concentration directly, just start dealing with the moles, because by the help of moles you can determine the limiting reagent. So this is the concentration of the salt, or sorry, moles of the salt. Now let's calculate its concentration. Nothing but moles by volume, which is 1 by 25. Any doubt? Guys, are you clear with this one? Please just inform me once. Are you clear up to this one? Everyone? Okay. Why students on the right hand side, on my right hand side, not responding? What are they doing? Yeah, the row in which Balajit is sitting. I am talking to that row. Are you clear with this one, guys? Okay. So we have got the concentration now. Just calculate the pH. Half of 14 plus 5 plus log 1 by 25. Okay, so this is half of 19 plus log 25 means log 5 to the power minus 2. Okay, so I need to solve this now. Half of 19 minus 2 log 5. So log 5 is nothing but 0.7. So this is 1.4. So 19 minus 1.4 is nothing but 17.6 by 2. So this is 2 8s and 2 8s. Guys, pH should be the 8.8. Do you remember that I have told you this makes the basic solution? So if it is making the basic solution, how can you get the pH value less than 7? See, if you are having the doubt in the calculation section, you can please just ask me. Please copy this one, guys. Guys, are you clear with this one? Please raise your hand, those who haven't got this. Raise your hand, those who haven't got this. Okay. What's your doubt? Can you please tell me? Okay, I'll explain the whole. Please copy this first. Copy this first. After that, I'll explain the whole. Copy and then confirm. Then I'll explain it again. copied. Okay, I'm repeating. Look at the screen. This is the reaction, the salt. I am repeating again that the C is the concentration of the salt. Okay. So check out. These are the moles. Okay. So the question is, how many moles? No, I guess two students have raised their hand. Just confirm me, do I need to repeat it or not? Okay, the Tamalong is saying the same. Okay guys, so I'm repeating it. Tamalong is also having some doubt. Okay, just look at this guys. The question is how much salt can be formed, means how many moles of salt can be formed. Okay. Yeah, by the time I'm repeating, you can just put your phone on charging. Okay. Okay. So the question is how much amount of salt can be formed. So for this, I need to use the concept of the limiting reagent. See, out of these two, obviously the production of product will depend on these two reactants. Okay, and I have discussed in the limiting reagent that what we have to do, divide the moles by their coefficients, which is 1 over here, and after dividing, whatever lower values we got will decide the limiting reagent, means will be the limiting reagent. Here the lower value is 10, that's why the moles of the salt formed will be what? 10. So we have got the moles of the salt. Now I need to know the value of the concentration. So what we do? Moles upon volume. Volume is what? 250. So on solving, you will get what? 1 by 25. And after that, just put the value in the formula and you will get your answer. Now clear, everyone? Now clear? And after that, this is just a calculation section. Okay. Let's discuss the last part. Hydrolysis of salt of weak acid and weak base. This is a kind of different case, guys. See, we are having the weak acid as well as a weak base. Okay. We have to operate in the same manner, but I'll operate with the acid as well as base. That's the only difference. Okay. This is the salt finally. This is C, this is C, this will be C. Okay. Now, CH3 will give you what? This one. Now the point is actually the both ions are reactive. Okay. The both on treatment with water give you what? H plus and OH minus ions. Okay. Now it depends then out of the anionic or the cationic part, which one is having the higher extent of dissociation or the hydrolysis. Okay. The substance, or we can say the species having the higher dissociation will make further solution acidic or the basic. So it totally depends on these ions, that how much extent is over there. Means it will depend on K and the Kb. If K is greater than Kb, you will say it is the acidic. If Kb is greater than K, you will say it is a basic solution. If both are equal, yes, they can make the neutral solution. Are you getting this? See what I was saying? The anionic part will definitely be treated with the water to give you CH3COH plus में OH minus. Okay, and here NH positive plus H2O will give you what? NH4OH and H plus. Okay, so the point is here K and Kb would be defined. Okay, so this is Kb and this is what? Ka. Okay, so the point is if Ka is greater than Kb, you will say it is the acidic solution. Okay, if K is less than Kb, you will say it is what? Basic solution. If both are equal, you will say it is the neutral solution. Means here, the nature of the solution will be decided on the basis of the values of K and the Kb. Okay. So I am writing the important formulas of this topic. Please copy before that. Copied? Copied, guys? अरे कुछ बोलो. I mean, say something. Yes or no? Okay, let's move on. First formula, Kw upon K into Kb is equals to Kh. Okay. Number 2, Kh is equals to H square upon 1 minus H square. Number 3, the most important, pH is equals to what? Half of pKw plus pKa minus pKb. And here, yes, H plus ions concentration is also important. So we will write that one as well. This is nothing but under the root Kw into Ka upon Kb. Please copy. After that, I am giving you the question. That's all about the hydrolysis. Over. Okay, I am giving you the question, and please this time give me the correct answer. Everyone, please read the question carefully. I am giving you the data, put the values and solve it. Okay, I need one correct answer at least in today's class. Okay, I know you will do the rest of the answers correct after that. But yes, in the first attempt, I need one correct answer from you guys. Okay. Is everyone ready now? No one is ready. They all are just laughing. They are ensuring that can we? Yes, we have to. Okay, I'm giving you the question. If you do the wrong solution for this one, then तुम सबको पाप लगेगा फिर. Everybody. Okay, look at the question. This is the salt of the weak acid and the weak base. Okay. Ka is 10 to the power minus 4. Kb is 10 to the power minus 5. pKa, wait, why will I calculate the pKa? Determine the pH. Determine the pH for this one. Tell me the nature of the solution: acidic, basic, neutral. Wow. What is the pH value? What is the pH value? How many of you has got this answer? pH should be the 7 and acidic solution. Means this is according to you, not according to me. You are saying this. So how many of you are saying that pH would be the 6.5 and it will be the acidic? Okay, Annie is saying he has got this answer. What about others? Can I start? Okay, how many of you has got 6.5 as a pH? Please raise your hand. Okay. And what about others? What do they have got other than 6.5? Okay, let's check out this answer. Let's see. pKa would be the 4. pKb would be the 5. pH is nothing but 14, means half of 14 minus 4 plus 5. Sorry. Plus 4 minus 5. So this is nothing but 14 plus 4, 18, 13, 6.5, acidic. Finally, we got the correct answer. So congratulations to all of us. Okay. So guys, that's all about the salt hydrolysis. Okay. That's all about the salt hydrolysis. So let's move on to the next topic. Okay, guys, before copying that, just listen to me very carefully. In the salt hydrolysis, the important point was acid and the bases having the equal quantities. Okay. After that, we were getting the salt. Okay. Now, it would be different. Acid and bases are in totally different quantities. So, what will happen? That out of acid and base, one of the quantity will totally get finished. Okay, yes, we'll definitely have certain salt, and along with the salt we will have either acid or base. Okay, so that makes them as a buffer solution. Okay, we'll talk about what buffer solution actually means. Okay, but before that, the question is why there is existence of the buffer solution. Okay, so I'm just saying that whenever acid and base are in unequal quantities, okay, remember I'm talking about the weak part, not the strong parts. Okay, because strong parts cannot react further. Okay, so whenever the weak acid and the weak base part are not in the limiting reagent, means they are in excess, and after formation of the salt they will also be left behind over there. So we will have finally in the solution a salt, a weak acid or a weak base. Okay, that makes them as a buffer solution. Okay, so just remember, buffer solution will be formed by the mixing of the unequal quantities of the acid and the bases. Okay, so let's write this first, and then we will see that what buffer means. Okay, please copy this one. When amount of acid and base are unequal, okay, let's say suppose we have got the weak acid plus strong base. I know the strong part is always will be in the limiting reagent, means it is considered to be limiting because it gets totally finished. So this is the limiting reagent. I'll have salt plus water. Okay, so in the final solution actually I have left with the salt and the weak acid. Okay, this makes the acidic buffer. Okay, let's say suppose we have got weak base plus strong acid. Again, this is the limiting reagent. We'll get the salt plus H2O. This makes the basic buffer. Means right now you need to understand only one thing, that buffer will always be formed when we have salt along with either weak acid or weak base. Only then we can get the buffer solution, otherwise we'll never have the buffer solution. Okay, and we can get this whenever they are mixed in unequal quantities. Okay, are you clear up to this one? Are you having any doubt? Okay. So let's discuss what buffer solution means. Guys, actually the buffer word stands for something which is not change, something which try to resist the change. Okay, means they don't want to change, they just want to be in the state in which they were initially there. Okay, so buffer solution means those solutions which will try to resist the change in pH. See, how can you change the pH? Let's say suppose you have an acidic solution, so you can change the pH by diluting it, by addition of small quantity of the base or small quantity of the acid. Okay, so by the help of these general phenomena you can change the pH. Okay, but if you say that a solution is buffer, then on the addition of the, we can say, the water, acid or base, they won't change their pH, they will resist to change in their pH. Okay, and all those solutions will be termed as what? Buffer solutions. Are you getting this? That the buffer means the solution which try to resist in its change in pH, okay, on addition of small amount of acid, base, or on dilution. Any doubt about it? I'll write its definition. Just you have to confirm me. Are you clear with this one? Okay, not clear. Okay. Which try to resist the change. Guys, listen to me very carefully. Listen to me, those who are having the doubt that buffer means which do not want to change. So buffer solution means a solution whose pH will not change. I was saying, how can you change the pH? In how many possible ways? Let's say suppose you are having the solution whose pH is 3. Okay. Obviously, if you add water into it, then total concentration of the H plus ions with respect to the solution is now changed. Okay, because we know that concentration depends on the volume. If this happens, it means that the pH has changed on the basis of on the dilution. Okay. If you add more acid, H plus ions concentration will be increased. Again, there will be change in pH. If you add base into that acidic solution, it will neutralize the H plus ions. Again, the pH will be changed. Okay. So these are the solutions. They can change their pH. Okay. If you say a solution is a solution is buffer, it means that on addition of such quantities like dilution, acid or base, they won't change their pH. If a buffer solution has a pH of 4, it will remain the 4 even after addition of small quantities of the acid, base or on dilution. That's what the buffer means. Now are you getting this? After that I'll write its definition. Are you getting this? Okay, so please copy this definition, that a solution whose pH does not change on addition of small amount of acid, base or on dilution. Okay. They contain both acidic and basic part. Okay, this is the buffer solution means. So let's write the properties of the buffer. First, constant pH. Second, pH does not change on standing long. Means if you keep those solution as it is for a long time, even then they won't change the pH. Okay. Please copy and then confirm. copied, guys? Okay, so guys, what we have to do, we have to just write two formulas and we have to write a few questions on that, and after that we are left with the solubility product only. So in the next class, we will wind up this chapter and we will start with a new chapter. Okay. And please keep practicing the MTG book that I have provided to you and ask your doubts as well. And second thing, what is the second thing? Yes, work hard, okay, because exam is almost there, okay. So please increase your efforts, your study duration, okay. That's it, and thank you so much, guys. All the best to all of you. I'll see you next time. Till then, take care. Bye bye. Have a good time. See you next time.